So right now I have three peer-reviewed publications, and that's in the Journal of Applied Mathematics and Physics. And right now I have, I'm still building on that. I have another one. So my last one was just published middle of June. It highlights more. It's kind of different scenarios. It's kind of going into further and further definitions.
Yeah.
Last one was on time itself and defining a 0 point in time, which isn't used in physics right now. And I have a paper right now under peer review, and it's looking at introducing a new timekeeping system for the moon to help international communities and agencies with their problem of telling time on the moon.
Wow. So how do you get fascinated by time?
It just seems, it's interesting because even it just seems like a logical place to start.
Right.
So you got to start at the very beginning, and understanding how time works kind of unfolds how you can model things.
Right. Wow. And so what is the issue with the way this time is done now in physics?
Right. So I'm actually writing a manuscript right now that I'm hoping to kind of differentiate this out. So modern physics uses work on Aristotle. So I went back and I read Aristotle's work on time and his works on physics. And he actually defines points in time, just like the ancients did. Egypt said there's a 0 point in time. In Mohist, China, they described a 0 point in time with no dimensional quantity of time. But modern physics looks at a continuous motion and continuous time. So without time, you can't have change.
Right.
But so all physics is looking at is that continuum of time, an infinite divisibility of time. But what I show is that there are signals that you can catch from a real world system that mark a position on think of a linear line, I call it a universal linear timeline.
Yeah.
There's a point. If you have a 0-dimensional quantity of time on that point, it won't disrupt a continuum. Because a continuum has dimensional quantities. So if you take a point that's anchored in that has no dimensional quantity, it'll just be an anchor. It won't actually take away from the continuum. It just puts a marker there. So
Wow.
the idea of that quantum physics is the limits of our dimensional reality. When you you have quantum superposition, so you can have all these different states possible in what I would say is 0 time. And when you measure it, those states collapse to a single state. And that is the measurements that I take in my system. And so there's no time coordinate, there's no time interval, if you will. There's only a time stamp. So the modeling system I'm using is a representation of here and now. It's not the past, future, and present like in Einstein's relativity. They don't coexist. It's nothing but here and now. So there's multiple different positions of here. They're all over the place. You're here, I'm here. They're all different.
Yeah. And so how does this theory or I guess idea of yours work with the idea of going back in time through light? For example, you can James Webb's telescope has this argument that you can trace time back with light. You can pretty much look at the origins of the universe. You can go back to the Big Bang. Are you saying that doesn't exist, or that's not the right theory to look at it, or time doesn't exist in that way?
They're not mutually exclusive. So they're two different things.
Right.
So light itself is a memory system. So the theory of relativity uses light as a memory. So if an event happens in distant space, it takes time for it to reach us. So in essence, the light of that event is a history of what happened in the past. Right? But so our
Yeah.
observational state of what we see is the past. It is always the past. Light gives us past.
Mm,
Whereas
right.
right now, you're where you are in the world, where I am in the world. We're conversing in the now. We don't have to observe each other, which would take a few seconds. Well, we do through the optic fibers and all that kind of stuff, but we can converse in the now. That is irrespective of space.
Yeah. So, what does your paper changes about what we know about time or how we understand time and our relationship with time or how we value time? What are you trying to change?
I'm not so much trying to change things. I'm just trying to present another way to model time.
Right.
Right. So right now you can't. The challenge that we're facing in modern day when we're trying to go to the moon, building a moon station, or going to Mars, is how do
Mm-hmm.
we coordinate time across space? Because the theory of
Yeah.
relativity, there's a delay with light. There's also the challenges with the cesium 133 atomic clocks because they run at
Mm.
different speeds and different around different masses and different planets. The different
Yeah.
gravitational fields change them. So there needs to be a way to synchronize clocks across vast distances without having those challenges or overcoming those challenges. And there's a lot
Mm.
of international exploration right now to try to solve that. So my system allows for, that's just currently in publication or in peer review, is it allows for us to create clocks and calendars of what's called universal time. So universal
Mm.
time is not affected by relativity. It is it's like a tree falling in a forest. You don't need to observe it for it to actually happen. And so there's like let's give an example. So let's take a duration of time, an orbit of the moon around the Earth. So that orbit of the moon around the Earth will happen in the real world setting, whether or not we're observing it or not. Whether or not we take a stopwatch and see it from Earth or see it on Mars or wherever we are, that has one duration. But when we observe it and we're using light as that measurement of time, it will vary on how fast we're moving relative to that event or how far we are away from that event.
Mm.
So, by understanding that you can create a universal time, then you can correct for that observed time versus the real time. And by correcting on all the different frames for your observed time, you can measure the exact same duration. So you can synchronize your clocks to the real world event, no matter where you are in space.
Right. That's fascinating. So is this a connection issue? So is it a, if for example, if we communicate, something on Mars, let's say on the rover that's on Mars, I'm sure there's a delay back and forth in terms of when did that event actually occur on
Yeah,
Mars,
right.
is that a connection issue, or is it actually inventing something new, which is a universal clock that allows to keep a synchronization of time across different planets, so to speak, in the solar system? Which kind of leads me into SpaceX and their idea of creating a Starlink chain of satellites between Earth and the Moon and Mars, where we speed up the connection point of data that goes back and forth. So there is a much more faster stamping of time for real world events on vast distance between two bodily planets.
Yeah, that's the communication system is still being used by light or radio signals. So there's always going to be a limit and there's always going to be a delay. So that's the current technology of transmitting information. So instead of thinking of it as like we're still going to need that if we're having radio signals, but instead of saying it, let's say we want to land on the moon, and you're on a spaceship, you're on the Mars. There are three people, one on Mars, one on Earth, and one on a spaceship. And you say, okay, I want to land on the moon at this moment in time. Everybody's clocks will tell in universal time will tell you that exact same moment in time. But if using relativity, and you're using an atomic clock for your frame of reference for where you were located, it's almost impossible to synchronize and know when that exact moment will happen. They're always going to be a little bit different. So the way I'm proposing is a way to synchronize all your local frame clocks to the same universal clock. So when you say, I want to land on the moon at 0-100 hours, let's call them hours, then everybody, no matter where you are, will land on the moon at 0-100 hours. You will have your lunar clock, you'll have your Earth clock, you'll have your satellite clock, you'll have your Mars clock, but everybody's moon clock will be the same in the universal time frame.
So how do you build a universal time frame? How does this become something standard that I on my iPhone can choose to have a clock that's on universal time?
It's very simple, but the simplicity we all like to try to make it complicated, and it's not that complicated. What we do, I already have an app that's available you can download, and it gives the moon time, and the moon division of time is based around the Mesoamerican timekeeping system, which I also decoded from Neolithic sites in Europe, as well as my second publication talks about how it's a potential lunar calendar system of ancient Egypt. So it's downloadable, and you synchronize. Basically, you take this universal time and you measure it using relativity from your specific location. And by measuring that through relativity, you can equate what your standard local clock is to that universal timekeeping system. And then you just transfer that into your app. And so everybody's app, if you're on the moon, you have this app. If you're on Earth, you have this app. If you're on Mars, you have this app. It's giving you the same moon units, but in your local frame clock.
Is this how the guys in SpaceX are thinking about managing time? Because, they're talking about doing hundreds and hundreds of flights, fully reusable, starships landing, refueling 5 minutes, taking off again. So they need to be on top of time and when they land, when they take off, and what's coming in, what's going out. They're dealing with, the opening window between Earth and Mars, which comes every 2 years. There's a 6-month window to travel back and forth. Is that how they're going about thinking this?
No, this is brand new. So nobody knows internationally how to solve this issue yet. So this is a brand new concept. Well, it's not a new concept. It's just newly described. So in 1905, Einstein discovered and described something. He said, if we're equating everything to the same proper time, there's got to be a global time. And it's what I call universal linear time. He called it global time and I call it something different because I'm not using frames of reference as he did. I'm using points of reference. So there's a nuance difference that is creating the ability for it to happen. And this is coming from my work in the ancient sites and understanding points and here, if you will, versus frames or planes of reference, an observer point of view, if you will. So the theory that I'm building out in the literature isn't new. It's just kind of an ancient system. It's based on relationalism. And Lipsnick was the first in the European setting to talk about relationalism, but he tried to convert it using calculus and continuums. And that's because they're trying to harmonize it to all the same mathematics. And when you take out that calculus component and you put it into what's called discrete, so you're taking steps and you use points and lines rather than a continuous flow, then you can create this ability. So relativity is used to create the metrics. It's the best we can use right now, but you basically can add another layer of understanding to how to model time. So it's this universal. It's interesting because Newton called it absolute time and absolute space, and it's not that, because absolute time and space, as Newton described it, was across three-dimensional space. And that doesn't, we've proven that many times, it doesn't work. Theory of relativity came in and could make better predictions, and that's why we have curvature of space-time, etc. But everybody was interpreting Newton's work through three-dimensional space rather than through a point. So what I'm introducing is time goes through a point. It doesn't go through space. And what
Wow.
I mean by that is that Einstein, you can't have time in Einstein's theory without space, because they use light to measure time. So if you can't have the movement of light, you can't have time. So in the theory of relativity, all calculations, everything collapses when you have zero, because you need to measure time and space by light. So in my system, I don't need light. I just need a duration. And a duration for me is unmeasured. It's just the orbit of the moon, for example. Only measuring it creates a dimensional timestamp in the frame of reference you're in. So
Right.
that duration is universal. It will only always be this, and it's linear and it's proportional. So if you're going really fast, time slows down. So in your calculation, I guess you would consider it longer, but it's not, but you'd convert it back so it's the same size. If you're going slower, then it'd shrink, and then you'd have to convert it back so it's the same size. So those theories, the calculations of relativity, will help you convert that back to the same duration.
Isn't it? I'm gonna weave here and and digress. But isn't it true that if you are standing near the pyramid of Giza, time is slower because the object is so huge that the gravity of that object makes time slower
In the sense of relativity, yes.
in the sense of relativity. Um, so do you have to send some equipment on the moon to measure the orbit of the moon and the size of it and the time, and then convert that into these points of reference for you to create that universal time on the moon?
Yeah, so that's what we're currently doing. So I've created a company. I've spun off a company from the technology, and it's going to do just that. We're working through collaborators. We can set up the moon system as well as the Earth system, and we can set up like the clock, if you will, on starships. And once all the math and the databases are all set up, we'll be able to greatly predict this. And it's a longitudinal system. So the more we measure, the longer we measure these durations, the more accurate we will be in our predictions. So it's not, there's a nuance here that we're introducing. We all use a standard unit of measure. We all have gone into that because we've realized that, one day is different from the next day. So we use the standard unit to try to say, okay, this is a standard unit, taking out the variability of Earth's rotation, and it's used universally across the world, and this is what we use in science. And we need that advancement. But we've forgotten, if we go back and we look at that division of Earth's cycle into 24, Earth's rotation into 24 units, I'm calling that a ratio unit. So that ratio unit of 24 is unique to that rotation. But the formula of dividing one rotation into 24 equal parts is the constant. So you can then create a linear longitudinal measurement that you can anchor one specific rotation of Earth in history if you know down to the nanosecond or further of how long that orbit that rotation took. And so once you understand the determinate nature of forces and rotation and earthquakes and everything like that, you can get more and more accurate on predicting how long that next duration will be. So it's a longitudinal assessment that is going to give us a lot of future capabilities. Basically, what I'm showing is that I can geometrically represent time and space. And if we know the exact duration of one specific thing, we can convert that into a geometric element. And we can decode that geometric element to say, well, this actually happened 10,000 years ago because that matches our records.
Yeah. So does this solve the problem of, I guess, time in history and stamps in history, where if we look back at history today, there's so much we don't know about history? time is such a modern thing, which is bizarrely insane, because you think about the universe been around for billions of years and the Earth's been around for millions of years, but we're still arguing and having these heated debates about what happened 12,000 years ago, whether it's true, whether there was an advanced civilization, you know. And Graham Hancock is a great character that just constantly gets assassinated on online with all these critics, like, oh, no, this theory is wrong, that theory is wrong. Is this this approach, this fairly new way of thinking, is it going to solve that kind of issues where, for a million years to come, if the human civilization survives, we can still retain the stamps of what happened in 2024?
Yeah. So think of if a solar flare happened right now, all our computer systems would be fried. There'd be no record other than anything written.
Wow.
And so think of all the pictures you take of your meals and your, all that kind of stuff. They're gone forever. People are like, well, did they know how to write and read and write back then? Because
I am praying for a solar flare right now. I just wanted to take out the entire system of TikTok. I'll be happy.
So the system that I'm proposing, that I'm finding in the modeling of Neolithic stone structures, is that these stone structures are data repositories, and it's like reading a line of code once you understand how it's all put together. And so if we can figure out a way to model a real world scenario of our planets, the location of them, the orbital speeds, the velocities, the tilt of the planet, etc., down to what hour in a day, you can even put it to what nanosecond in a day. I could show you how to do that. We can record when we had this conversation using nothing but a point and some dots.
Yeah, wow. It's funny because, like, when we do a lot of things, we don't really record them. There's no timestamps unless we post it on social media or we do a tweet on X. Then there's a timestamp for recording my memory of that event, but there's no timestamp for that event actually happening.
And our timestamps we use now are mostly, not universally, mostly associated with the Gregorian calendar system, which is abstract. So if you assign timestamps based on celestial motion, that's not abstract.
So you're telling me everything has so far happened in my life is just fake? They're all
it can go away with a big caboose of the sun.
It's just boof. Yeah. This is the last time I did iboga, which is a psychedelic drug experience, like ayahuasca. When you do that, you're like, fuck, everything that has just happened to me in the last 30, 40 years just means fucking nothing. It just went boof,
Perspectives change, I tell you.
Yeah, it does. That's crazy. It's such a very simple concept that we don't think about. We're so distracted from, what's the latest, who's killing who's starting the next world war, and who we're going to vote for. But these basic simple things.
Yeah, they're all those things you're talking about. I don't know. I think we need to understand that there's more out there and knowledge is more exciting than who got the most votes on a thing. There's so much capability out there in discovering who we are, and that's very, very positive. And unlocking the potential of our history is phenomenal. I'm learning from my sites and decoding ancient sites is that these, like we said, they're timestamps. You can, once you understand most of these sites, at least the ones I'm studying, you can understand when they were put together, and once you understand when they're put together, well, then that opens up testing the hypothesis. Well, let's test that. Does that match carbon dating? Does that match our current anticipation? And then you start to understand that the complexity of the mathematics that this is starting to unfold, and the simplicity of it is just mind-boggling. It's a harmony. It's a symphony of mathematics and geometry, and it's not abstract. We've converted all Euclid's geometry into this abstract interpretation. Euclid's descriptions of geometry are simply a template. And then you can add in information. Let's make this line not an abstract line, but let's make this line from the earth to the sun. Well, guess what? Now that's a geometric line. And you can scale that. And then you can scale that and put it on the size of a countryside or in a Neolithic structure. And if once you know how the scaling system works and all the formulas work, this all just kind of explodes. And our history, our conflicts, everything that we look at will come into perspective that there's more here than we could ever imagine that we were a part of or that was a part of before we got here.
Do you think that you are solving a intelligent-based problem, or are you solving something that is much more higher in that the human frequency can deal with? This, do we really fully understand maths? Is it something we invented? Is it something we discovered? Are you leading us to this path that there is more to be discovered that changes how we connect human emotion with time and memory, and how we view everything that we, I guess, capture to the resolution of our eyes and our senses and our memories?
And all those questions you've raised are the exact same things that come to my mind. It's because it's in even just the understanding of how you can model the universe in a different way than is currently done through observation. So basically, I'm looking at modeling a system above the observer. So right now we approach physics as the observer. This system kind of steps above, and I'm looking at the observers, and I see multiple of them.
Yeah.
So that creates an entire new framework for understanding how space works, how time works, how to see the universe unfold, and it ties in computer theory, which it's showing that humans have been really advancing a lot of the technology in the right direction, but they've been missing a little simple formula. And we use it every day. That's what I'm finding so exciting, is that 24 hours in a day, well, that's 24 times 60 times 60. That's the division of a rotation of a body. And so you can model where you're rotating and how far it's rotating based on that division and how many counts. And it's a modular approach.
Yeah. And does it change our ability to advance our capability as human beings? Like you know, there was recently a UFO hearing in the Congress with Representative Nancy Mace. She was sort of championing it. And one of the things that was quite fascinating is the G-force these UFOs pull. Like, we as humans, we can't do more than 13, 14 Gs. But these UFOs are pulling 1,000, 3,000 Gs. And doing it the way that you're proposing, does it really advance us to a next level in terms of what we're capable from a technological point of view?
I believe so. I don't think they're pulling those Gs at all. I think they're experiencing 0 Gs.
Wow.
Because
so they can just disappear with like no Gs. They can.
Don't think of it disappearing. Think of it as phasing between matter and energy. So if you can phase between a particle of energy that is moving in this direction at this speed, constant velocity, and then you dephase into, and then you change your coordinates, and then you rephase going in this direction at that velocity, you're not accelerating. You're experiencing that shift outside our physical manifestation.
Wow.
So you just be going just like my arm. You're phasing in and out of a dimensional a physical form, and you're changing your energy to that where you're going. So you have this energy, and then you rephase it, and you now have this energy. So you go there. So in essence, if that is possible, if that exists, you wouldn't be experiencing anything. You'd just be sitting there.
Wow. And this is a different concept to telepathy?
I would say it is. I would say it's more similar to the concept of teleportation. So if you can phase
sounds
between,
fun.
Yeah, it does. But see, this is how
Hit me, man. I need one of those. I could be like, I want to go to Tokyo for the weekend, just zoom. Yeah, 2 seconds, and I'm having just go have a coffee in Paris, and then come
There,
back.
have a croissant and you're good to go. And have your crumpets
That's a
in New
cool
York.
world to live in. That's a cool world. Imagine people living like that in a million years' time, right?
Oh yeah, yeah.
Just go
And
to Mars.
well, see, that's the thing that this system allows for is that my proposal allows for zero time in our dimensional reality. It doesn't mean that there's time beyond our dimensional reality. It just means as we experience it. And we get that in quantum physics. We see a particle existing and not existing. It's discrete. So what I'm saying is that quantum state is just the conversion of solid energy matter into energy and then back again. So if you slow a quantum state down, you get into solid matter. If you speed solid matter up, it starts phasing between matter and energy, and then it just converts to pure energy beyond that. So I have a poster at a physics conference, for example, where the inside of a black hole does not have a singularity, and there's this challenge of physics. They don't know how to resolve a singularity. It's not possible. And so for me, I have no singularity. Inside a black hole is really, once you get to the event horizon, you've converted all matter to a frequency and a vibration of pure energy. And so inside the black hole is not the lack of escape of light. There is no light. It's just pure energy. And that's why you can have Hawkins radiation, because now energy is not affected by gravitation and it can just evaporate.
Yeah. Have you watched the movie Interstellar?
Yes, yeah.
Now, in Interstellar, the movie is built around time, how he travels through these different parts of the universe, and he spends a lot of time near black holes where he ages very slowly compared to people on Earth, and when he comes back on Earth, he's meeting with his great granddaughter, and she is like 130, and he's still 30, 40 years old. Is that movie built completely on the concept of relativity and
I,
time?
w- I would say so, because it's getting close to the what's called the twin paradox. So if one person's on Earth and then they have twins, one person stays and the other one goes, they're going to age different. So it's very much
Yeah.
aligned and describing the twin paradox, and that for me is a paradox of relativity. I don't have that paradox in relationalism because there's only here and now. And there's another paradox in relativity called the box universe. So the box universe says the past, the future, and the present coexist. Everything's already done. It's just being played out as we're experiencing it playing out. That's a necessity of relativity. It's a necessity of the mathematical tool. Through relationalism that I use, that doesn't exist. There's no such thing as time beyond the present. For me, a duration of time is the duration between two instances of now. That's time. And that is universal for you or for me. So here for me, if I wait like that, whatever it is, that duration between two clicks is the same for me as it is for you. And it could be the same for you if you're going around the black hole, where only by relativity are you getting this delay, not by relationalism.
So how does this change when we have a city on Mars, a million people living on Mars? They would have, local Martian times. They'll be spread across the planet. They'll have their own different time zones, Eastern time, Western time, and so forth on that planet.
Yeah.
And then there is a universal time, which is what you are working on. And then there is Earth time. How does that all coordinate with each other in terms of markets and stocks and
Well,
planes and
so you,
flights and
yeah, I would think more. I think more around logistics than economics, because
yeah,
economics is
sure.
fun for some. I want enough to keep buying books and reading.
Yeah,
Um,
yeah. Just keep it to Stone Age, 4,000 years on Mars before we start get silly with Bitcoin and
yeah, exactly. Well, it gives some people things to do when they have nothing else to do. Excuse me. So think of it differently. Let's expand it further to make the point a little bit different. So let's say there's another civilization we colonize, or another place colonizes us, whatever you want to say. Let's just say another star system, you're on another planet. Now, we can celebrate Happy New Year's for that other planet at the exact same time. So you can have the galaxy doing a countdown for Happy New Year's for Earth, and you all celebrate at the exact same instant.
Right. Wow.
And you all have your clock of Earth, and you have your local clock, and you know when that Earth reached whatever you're looking at as the signal for the new year. And you can't use the Gregorian calendar. The Gregorian calendar is kind of it's a mishmash of multiple different things shoved together, and it's the more ancient calendars like the Islamic calendar, the lunar calendar from China. These are much more in tune to the natural rhythms of the real world system. And so it's not necessarily saying, oh, let's arbitrarily pick January 1st as a new year, which is arbitrarily in Earth's orbit. Let's pick a new moon. Let's pick Earth's location at the apex of one of its orbits, like the aphelion position. That marks the new year. That's what they do for Mars right now. And so if you have a real world cyclic event like the aphelion position of Mars, then anywhere on the galaxy can celebrate that as your new year.
So Mars has a calendar, like it has 12 months and 360 days, and we measure stuff.
Well, there is a calendar, but it's mostly on a year calendar. They haven't broken down into months. And I was working with NASA. They do have Mars 24 times. So just like Earth, they divide the orbit or the rotation into 24 units, which is a little bit different than ours. Not much actually. And so I built that into my watch system. There is already kind of, if you will, time zones, 24 time zones around Mars. That again is just extrapolated. It's not a universal adopted standard. I corresponded a little bit with NASA to try to set it up for the app. The division of a duration of time, you're saying 12 and then into 30. That is the division of a universal duration. So that universal duration could be one Earth's rotation, could be one Earth's orbit, could be one orbit of the moon around Earth. Any duration can be divided into 12 and 30 and 30 and 30 and 30 to get smaller and smaller fractions. So that's important because you create through geometry symmetry of time. So 12 is a dihedral symmetry of time. And I see that in the geometry structure of the structures itself. And 360 is this dihedral symmetry of a spatial relationship. So we only use 360 divisions or degrees, excuse me, of the circumference. But if you take that circumference as a string and lay it down, you can also take the 360 degrees, if you will, units of a measure of a line. We, for whatever reason, have only been using it as a circumference, but you look at all the ancients and they use it as a division of a spatial measurement.
That's so cool, so fascinating. So what is this app called? Is it the app that you're building? Is it live and people can get it
it's
on
live.
the
It's been
iPhone?
out. I built a beta version 2023, I think. I launched it into Android. It was just a beta version. I took it off after about a year. I then launched it into iPod for iPhones or iOS. It's called Vartis 12. So VARTIS 12, vartis12.com. And it's just a widget. It's starting to see if people like it. I have a lot of ideas to how to expand it. But so it's a widget for your iPhone. You can put it at Mars time, Moon time. And then also you can have it for your iWatch if you're interested in that.
Wow. Yeah, definitely getting this app.
So the word Vartis means orbit in Sanskrit.
Okay, cool. And I can get times for Mars, for Moon.
Yeah, you can pick if you have, let's say your Mars rover of interest is on whatever time zone on Mars, you can select your clock to be on that time zone.
Wow. That's cool.
Yeah, and then the Moon 18 is a division of one lunation. So when it goes back to 00, like a new day, that's at a new moon. And so a full moon is 900.
Wow, love it. Vartus 12, join timekeeping beyond Earth. Vartus 12 uses a shared technology from ancient cyclic time combined with modern advancements of linear time. This app will continue to advance and connect you to time beyond Earth, beginning with Mars 24 and Moon 18 timekeeping. Okay, yeah, I love it.
Excellent.
That's so cool. And have you tried to get this sort of app and thinking in front of SpaceX?
Not SpaceX yet. I'm working on it. I'd love to, but I'm just a guy saying, "Hey, I have a solution." When that's everybody in the world is on the stage trying to figure out the solution already. So it's challenging.
It's like, hey,
Hey, I'm over
maybe
here.
over here.
It's over here. I'll explain it to you. So it's a
That's
bit difficult.
hilarious.
But I have been invited. So Washington puts together a yearly conference. It's called Space CISA, Space Exploration and Strategic Applications. So I've been invited 2 years in a row about time and space and giving the presentation. That's where I currently have a paper in review, and it's a lot of the work that I published thus far is simply the theory of relationalism and how you can use it to measure time, but it didn't talk about how it compares to relativity. So now the one in publication right or in peer review right now will say this is how it works with relativity.
I guess
And
that's kind of the main connection point because so much of the world's reality today is built with that whole, time with Albert Einstein's theory of relativity, I think.
yeah, and it's fantastic. It works very, very well. And the relationalism works in synergy with it. So I used to say, "Oh, I'm advancing it," and then as soon as I said that, everybody closes their book and says, "Thank you very much."
Yeah, yeah,
And
yeah.
so I
Just
had it's semantics. It really is. And so when I'm at a point where I'm approaching dogmatic beliefs,
right.
and it gets a lot of resistance, especially by people who have a very vested interest in that dogmatic belief. I've presented new proposals for calendar systems, which I have phenomenal data on. They won't even consider the data because I showed them just how the Mesoamerican timekeeping system can be changed into a different hypothesis. And so I reach out to scientists and say, it's a hypothesis. Let's just test the hypothesis. Let's sit down as scientists. Here's a hypothesis. Let's interrogate it. And I get very angry responses. And that to me shows that it's more of a belief system rather than a scientific endeavor.
Yeah, yeah, yeah. I think you would find that this whole science world with peer reviews and it's so much of a belief system than actually a scientific system that people are, I'm not part of that world. I'm not science, stuff like that, but it definitely comes across that it's almost like an exclusive club for some sort.
Oh, it is. You got to speak the language. Like for instance, so I have a PhD. I have, I think about, I forget how many, maybe just over a dozen, maybe 15, 18 peer reviewed. I've been cited over 650 times. And it really is just, you got to know how to speak it. You got to know how to present it. And when I come into a new theory or a new area, it's really challenging for me because I'm not an expert in some of these areas. Like I'm talking about Euclidean geometry or areas I haven't studied, but I can't speak in that language. So I do my best. That's all I can do is do my best to try to explain it, hoping to get to a point where I can collaborate with experts.
So how did
So
you get into this? Is this something like, do you spend a lot of time in universities doing as a professor? Do you teach, or is this something from university that you just got into becoming a researcher? Or
no, I basically stumbled down a rabbit hole, and I've always been very curious. I've always been thrilled at challenge. If there's I remember when I was doing a fellowship, I did my fellowship at Harvard, and I was giving two projects. They said, okay, this one is really, really well established. It's funded. Do you want this project, or do you want this project where nobody's working on it, but we think it's a really good idea? And I said, take me the one that has a great idea and nobody's working on it. That's the one I'll do. And that just seems what I do.
Yeah.
So I love that kind of discovery setting. So when I'm trained in genetics, and I'm a medical scientist by training. When I was, it was during COVID, right before COVID lockdown. So it was this last week in 2019. I was watching a documentary, and it showed geometry of ancient sites. And I immediately recognized the geometry. I said, those are the relational patterns of this. That's the ratio of that. That's the ratio of that. They're proportional. This arc is a representation of an orbit, and this point of that arc is the representation of the parent body. And I just took a picture with my camera, and then went down and started doing calculations and learning the math and going through Google and understanding it. And the more I went, the more it kind of started supporting each other. And I'm a scientist, so for the first couple months, I was doubting myself. And only through the repetition and the modeling system and redoing it, my confidence in it eventually built. And the way I feel that is, if it was wrong, if I was going in the wrong direction, it would eventually crumble. But as I go further and further, it's actually building more and more, and it becomes more harmonious and synchronous with everything I'm discovering.
Yeah. No, it's fascinating. I was actually looking at this bat cave that's like 4,300 years old, and it's in this bat cave in Jamaica. They have like a 2 meter high poop core of all the bats that's been shitting for the last 4,000 years. And it's so fascinating when we talk about time and relativity. Scientists go and take samples of this bat shit basically, and then they can go back in time and study climate changes. They can study food sources. They can study a lot about bats by simply taking these samples of these like bat shit, right?
Yeah.
Which is batshit crazy, right? And then that becomes timestamp in history based on relativity of how bats evolved, the evolution of bats, right? Which leads me to this whole, ancient world of pyramids and stone technology and carving stones. And what's your sort of experience and understanding of this whole ancient world, advanced technology, how they used to measure time? How is that different to the modern way we do things with the theory of relativity?
I'm finding I'm finding consistencies around the globe. So the measurement system I'm using is called these ratio units, are object specific. So we use 1 meter, and we use that as our standard unit. They build their systems based on ratios of objects. So that's why it's no real big surprise. I didn't discover this until after. I didn't study any of this. I'm like, wait a minute, that maybe, and I did some calculations and like, oh, Khufu's the size of like, it's a scale of Earth. And then I did some reading and found some books. I'm like, oh, they already knew that. Okay, fair enough. But that's one example. There are multiple examples of this. And so what I found is that when I go around the world, they're all using the same geometry, the same math, the same units of measurement, and the same understanding of time. They all use signals of the real world system, alignment to the sunrise and summer solstice, the equinox, the vernal angle, all this kind of stuff. It's all used, and they're all signals that create points in zero time. So all these sites are built in the same theory of physics, if you will, that there are zero-dimensional points in time. And relativity, our modern physics, everything since Aristotle has argued against that. So all our formulas can't work without having time present. That's why it goes t equals infinity to t to infinity. Excuse me, because the formulas break down. They don't exist. So I'm starting to introduce formulas where you don't have to have, you can have zero time. Because without zero time, you have a length. You don't have meters per second, you have length dot t. It's called absment. So there's an entirely new way to model physics using discrete steps rather than a continuum. But it's going to change. I'm just now starting to try to figure out how to put together new formulas. I'm introducing new formulas for absment, which is right now only used for the flow of fluids, basically, for whatever strange reason. So it's using, instead of time derivatives of displacements, it's called, which is velocity and acceleration. It's using time integrals of displacement. So that would be absment and absity.
Wow. And your new paper that you're working on, is that gonna allow us an ability to compare and go back in time and decode timestamps based on relativity and do it based on your system? Can we go back in history and re-look at everything?
Yeah, so I'm proposing that I've already have some hypothesis for different sites that we can mathematically decode when these were constructed. And
Wow.
it's like it's not using relativity because it's not using an observer's point of view. It's using relationalism. So it's using, like, for example, I show a universal clock showing one orbit of a planet that's 12 light years from here, and it correlates to 1.2, well, it's actually 222 over 360. So 12 times 30 is 360. So 222 over 360. So it equates it uses Earth's timestamp of an orbit and a bit to say this is how long this orbit takes. And actually went and compared that that's just the orbital time. I have orbital distances and planets, etc. And the interesting thing is that it matches within the error bars of NASA calculations of the distant star system. So using just a ruler, a caliper where it can measure distance and scale, to a site survey, I can decode the precision of astrophysics calculations of this star system.
Interesting. So if we had a UFO that just came and crashed on Earth, are we able to take your principles and look at it and go, okay, this is when it was built? Or
maybe not. I don't know, because you take measurements of a planet, for example, when it occurs, but the measurements of a planet are very, very change very small over a small amount of time, right? It does. There's a lot of complexity to the modeling system. I know that's the capability of the system. I haven't got all the details out to that because this is, if you will, I wouldn't say inventing, but it's rediscovering the way it's done, and it takes a lot of time, and no pun intended. And it's challenging. It's challenging to figure out what is the next step I need to introduce to advance the story. Because I could go in and decode a whole bunch of sites, and I had to stop doing that because I had to go in and define what a ratio unit is. One paper I had to define how you can create a universal calendar system. How do you define a zero-dimensional point of time? So I had to take a lot of time and effort just to go and define basics. And then the interesting part is the decoding. But it's
so have you decoded? Tell me some examples of things that you've decoded that are sort of very simple but mind-boggling.
Sure. The one really cool thing is kind of tying into that. So I've decoded a star system 12 light years from Earth, and it has 4 different planets in it, and I can decode the angle, the tilt of the planet. And I can decode the distance it is to the star, and I can decode its orbital velocity. And I can decode it because it's called the canonical reference. So I know how Earth is presented in this model, and because I know what Earth is measured like, how Earth is represented, then I can decode how they presented this other star system. And so when I took the measurements of these positions, and then I took the angles, well, not so much the angles of the planets, but just the orbital distances and the velocities of their orbits, and I just Googled it, and I said, okay, it's this far away from Earth. What has 4 planets and da 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 da, and it came up with a star system that I then went and read the papers and corresponded with the author of the journal or the author of the paper and suggested, is this possible in the sense of distances and everything. And anyway, so what I was decoding from a site that's 7,000 years old was matching publications of interstellar star charts from the star system that was 12 light years away, just as I calculated, had 4 planets, just as I calculated, and the distances between the planets and the star was within the error bars of the publication.
Wow.
So I've proposed that the most distant planet, the distant planet has 3 moons, or it's either, I can tell by the orbital plane it's on. They're very similar. So it's either 2 planets, like a binary planet with 2 moons, or it's 1 moon or 1 planet with 3 moons. I haven't totally figured out which, but there are 4 celestial objects at this location, and that can be tested. Now, with the technology of today, if we point the satellites there, can we determine that there's actually not just 1 planet, exoplanet, which we're expecting, but are there a planet and 3 moons? And if we can do that, I've created, through the mathematics, a hypothesis, a prediction, and if it's tested and validated by another technology, well, it supports the hypothesis. It supports what I've decoded from the site.
Wow. What do you think the universe is doing? What do you think is the purpose of the universe? Do you think it's organizing itself in time and space to create life and consciousness?
Good question. I think we're just. I get excited because that can mean so many things. One explanation I do like that I kind of resonate with, whether it's not true, it's not my idea, but it's that we're just here to experience things and learn. And in a sense, we're here to learn about ourselves.
I get that. But I think my question is, we are a byproduct of the universe, right? If you think about what we are made of, like 70% of what's in the universe is what we are made of, right? So this idea that the universe is organizing itself to create planets, and then there's life, and there's single cells, there's multi-cells, and there's us, and then there is consciousness. There's life and there's consciousness, our ability to think about ourselves and about the universe and the time and space around us, which is what you're doing, right? So that's sort of do you believe that the universe is actually doing that in some sort of way, that it understands that it's designing and creating itself in a way, organizing itself within time and space to allow life to flourish, for us to experience the universe, like we are the universe. We are experiencing universe coming to life.
That depends on, I guess, what your definition of universe is. So I'll define the universe as a physical thing. So a universe is a distance between things and an experience of time. Now, our role or our part of that, are we tethered beyond this? So is there a dimension that is beyond time? And so I'm always curious of, is there a part of us that is beyond the time of our universe, which is directly affected to our dimensional reality and our scale of time? My last paper, I suggested, well, there could be multiple scales of time, and every universe has a fixed scale of time. So if there's another universe overlapping with us, and their Planck limit, if you will, for their Planck interval for time, is actually extended beyond the beginning and the end of our universe, well, then we wouldn't even see that universe, because it's so big that its atomic time interval is between our existence. So there's a lot of different possibilities of how we can experience the physical and still be potentially tethered with something that's not physical. And we're just here manifesting our creation and our environment based on how we manipulate energy and how we're interpreting energy.
Yeah, energy has a big part of it in terms of how we experience what we experience. So much of it is energy in many different ways.
Yeah, and if we're experiencing discrete signals and our brain is seeing discrete signals, which means a signal, it's not continuous. But we think it's continuous because that's what we observe and understand in our consciousness. Then there can be a lot of events in between what we experience in this dimension. And we're not privy to it because it's not in our memory system.
What other dimensions do you think exist?
Not dimensions. I think there's other dimensions, but the word dimension has so many definitions. You can talk about geometric dimension of 0 point and line and 2 dimensions, 3 dimensions, right?
Yeah.
And you can talk about dimension of time or dimension of length. In relativity, you need all these different dimensions. In quantum physics, you need all these beyond 3, 4, 5, 6, 7, 8 dimensions for the math to make sense, because they're locked in this understanding or assumption that matter is continuous. It doesn't need to be. But that's how we define it. So, dimensions can mean multiple different things. I don't know how to interpret
How
that.
does relationalism work or compare to quantum entanglement?
All right. So for me, I have a poster on this. Quantum entanglement, right now they think there are two particles that mimic each other. They're opposite, but they mimic each other.
They're entangled.
Yeah, they're entangled. Right. But they think right now they're two particles. Why can't they be the same particle? So you know when you're on an airplane, you see the propeller, and you think the propeller's not moving. It's just because it's going so fast, and the frequency matches, so you only see the propeller, even though you know it's on.
Yeah.
Now, what happened? That's a quantum particle. And what we're actually just seeing is the two sides of the same propeller.
But they're in two different spaces. They're clearly two different objects. Entangled.
Why? No, they're the same. They're in the two different locations at the same amount of dimensional time. But can they, right? So you can have time here and time here. It's just like looking at the propeller. It's moved a continuous amount, or it's moved, but outside our dimensional reality. So we're only seeing it when we see it.
Right.
So we see it as continuous as two particles, but it could be the same particle just witnessed at the same time.
Oh, okay. So there's a piece that we can't see, but it's the same
we
thing.
Can't see.
I see. So do you think that explains quantum entanglement? It's just a mimic of the same thing? It's actually it's not entangled?
It's not entangled. It's the same particle. That's my thought. So of course, if you change one, it changes the other. It's the same thing.
So could there be an Earth somewhere else that's just mimicked like Earth, like us, and both of us are having a podcast at the same time?
It could, and we've taken the conversation in different ways.
This is getting my Sunday way more excited than my Sunday should be.
We've created an infinite number of podcasts simultaneously. You're incredible.
I love that idea. That's cool. That's cool.
Yeah. So this whole physics of it that I'm proposing allows us to think of. People say, well, it can't travel faster than the speed of light. I totally agree with that as a dimensional point of matter. But if you can convert matter to energy, pure energy, well, then there's no limit to how fast it can go, because fast is dependent upon the dimension of time.
So can you convert human life and life on Earth in energy and move it into across multiple light years in a matter of
The instant.
in the
Instant.
instant into a different Earth-like planet, because there's billions of them just in our galaxy.
Yeah, so that's what the physics proposes. So if you have a basically zero dimensional time is not zero time as everywhere. It's just in as we see it. So if you can figure out how to, of course, this is all speculation, hypothetics, but this is what makes my imagination go. Is if you have zero time, if you can find a point of zero time, you can move an object from here over to here, and it didn't move in our time, but it's moved. So it's basically going snap. The same snap moves it from here to here. So you can you can go through space and have two relational coordinates at the same point in time. So if you create a Stargate or something like that, where you create a 0 point in time, if you put in a coordinate of where this object is and a coordinate of where you want to be, and you pass through a zero-dimensional portal of time, that would be the Stargate, is that you've now have a new coordinate. And that's the same thing as what we would see in the quantum physics. So you have a superposition of possibilities and locations in space. That's at zero time. So as soon as you have our dimensional time and then you go into zero time, you can pick where you want to go. All right, I'm going to pick that coordinate, and then I'm going to enter back into time. And now you're all of a sudden at that coordinate.
Wow. So how is that physically possible? How can I take a physical body and turn it into energy and bring it back to that physical body somewhere else in the instant?
Yeah, what I try to look at for inspiration is a black hole. So a black hole converts matter into energy. And so
Yeah.
there's got to be a way to speed up the vibration or the frequency of matter to the point where it becomes energy. And then you can slow it back down, and then it becomes matter again.
I'm looking at this, trying to find the name of this Apple TV show, which has just came out. It's called Dark Matter. Did you watch that?
No, I haven't. I'm trying to see if I. No, I haven't heard of it. No.
Um,
I know there's a
it's
three-body one, but
it's basically a guy. He's like a technologist or something. He discovers this black box, and in this black box, there are like a lot of doors, and he can open one door, and his physical body and himself can go into this new world. But what happens in the show is, because he invented this thing, now he is in all these different worlds, and they're all trying to get into his world. So there's like a million of them of the same guy, right? So if we open up this portal where there is like me somewhere else, and now he knows that he can get to Earth and have the life that I have. Let's say it's Elon Musk, right? And Elon Musk somewhere else is just poor as fuck. And he's like, oh, there's an Elon Musk on Earth. He's worth $348 billion, and he's building rockets. I want to get in. It's a drama. It's a TV drama, right?
that's fine.
Sci-fi drama. But that idea that we can create something where we can just take our energy and move it into this different world, but then we realize that we are already in that world.
Simultaneity. Yeah.
Yeah, we're already there. And then that same person goes, oh shit, Stephen, what are you doing here? Where did you come from? I want to go there. I want to experience Stephen in your world.
Yeah, no, it's all interesting. And see, that's the fun thing. And when you start to understand that there could be more out there beyond just what we observe, and the dimensionality of time and space, it opens up all these new ideas. It just helps us explore what could be possible.
Yeah, absolutely. Absolutely. Um, you believe in aliens?
Absolutely. I think anybody who I don't know, I won't say, I won't judge anybody who does or doesn't. You asked me, and I'll say yes.
So how do you come to the conclusion that they're real?
5 years ago, I'd probably be with everybody else saying, yeah, you never know. The probabilities of other intelligent life, given the number of da da da, the Drake formula, it's likely. But when I went through the studies of decoding these sites and understanding that there's absolutely no way possible for us to know this information, I can't figure out how could I observe something on Earth of the planets of another star system that I can't observe. You need a star. I can see stars. I can't see planets.
Mm.
And so, how can the planetary data be present on Neolithic sites in the world? The only hypothesis come from somebody knew this information here, somebody went there, came back with that information, or somebody came here with that information. I don't know any other scenario that could play out without that data getting here.
Yeah, what's crazy is that there is no evidence of life that have originated on Earth.
Sorry, what do you mean by that?
Like there is no origin. I mean, if you look at the life that started on Earth, I think there is an argument that life did not start on Earth.
Oh, okay.
It may have come from somewhere else. It may have been just through fossils or rocks or that have come
Asteroids or
and
whatever. Yeah.
asteroids. Yeah.
So for me, my evidence to support that claim comes from mathematics. So it comes from the fact that I can decode very specific information that's beyond our capability and understanding, especially 7,000 years ago, and for a star system that's 12 light years away. There's no other, as a scientist, as evaluating my findings and trying to create a hypothesis to explain those findings that can be tested. That's my most strongest hypothesis, is that we've been visited.
Yeah, I love these conversations because I often find myself in this reality where so much of the world that we consume are based on there's no evidence of aliens, so they don't exist, and that's the end of the conversation. There is no exploration and understanding beyond our dimension and intelligence, that the fact that the universe is so vast, there must be a different way for us to understand it, and code it and figure out what else there might be. And the best starting point is there must be aliens out there. And whether you use maths or science or whatever, observation, telescopes. I had Brian Corey Dobbs. He's a filmmaker on my show. He did the film called Blue Planet Red, and he basically studied how Mars used to be like Earth, and then it's turned into this. It's basically rust. The whole red on Mars is basically rust, and you can't get rust if there's not water. And then he studied all these different pyramid-shaped structures on Mars, and this idea that there is microbial life on Mars. But still, so much of what we know about Mars is we're still trying to find water on Mars when there are like thousands of subsurface ice lakes on Mars, and so much more evidence of there might have been alien life on Mars that maybe visited or maybe originated on Mars, and then they may have moved to Earth. This idea that UFOs for some reason always like to hang around our military sites, our nuclear weapons. They deactivate them, they activate them. So all of that stuff to me is super fascinating.
Mm-hmm. Yeah, I think I think the null hypothesis should be that there is something out there, and it's up to prove that wrong. because there is, like you said, there's so much evidence, and it's dismissed because it's not studied in the academic setting. What I find is interesting is I reached out to SETI. They actually had a publication where they said there's an ancient mathematics that we don't understand. We know that it existed. We don't know how it's created. We don't know how it's laid out. So I reached out to the authors and I said, I have a good hypothesis on it. Here's all my data, and would love to chat with you. And they never get back to me. So it makes me wonder, well, if their mandate is to find extraterrestrials, if their mandate is to look at all evidence, they're using a selection bias in that pursuit.
Yeah.
And
Yeah.
that's not science. That's
Yeah.
selection bias and research bias. It's a reflection of their funding body. It's not a reflection of
It
science.
is always follow the money, and that's what sort of Brian was talking about as well. Is NASA, you think when you don't engage with them, and you think of NASA from a distant perspective, you have a lot of trust in NASA that they do work based on science. But once you get involved, you're like, this is interesting. You actually don't do this based on sciences, whether politics or whether it's, the right thing to say, not the right thing to say. This idea that, we don't want to create a lot of fear, and we don't want people, what if people find out that there are aliens? Everybody's going to fucking freak out and this and that.
I
So
think
it's interesting.
that fear comes from being from the unknown, not the known.
Yeah. It's super interesting that becomes our reality. And then you have the likes of Elon Musk. They're trying to disrupt that kind of thinking, and bring in different thinking. Do you think humans went on the moon? Are you a moon landing believer?
Yeah, good question. I don't know. Like, I always think they did, but in the same breath, look how hard it is now. And they're having troubles with Artemis mission trying to get there. So it's like, well, with all the advancements and you're having trouble now, how was
Yeah.
it done so far long ago?
It's like the best thing to lie about. Because it's just right there. You're like, oh, yeah, of course we went to the moon. What do you mean by we didn't go to the moon? It's right there. And then at the same time, you can get into these really in-depth discussions about how we didn't go to the moon. And these, really good explanations. But the crazy thing about the world we live in now, you can bring someone on a podcast and he can convince you that the earth is flat.
Well, it's
Right.
interesting. I love the flat Earth debate, because my sorry to jump into that, but
Yeah,
my
let's
my
get into
addition,
that.
my addition to that is you can model the Earth flat. Does it mean we observe it flat? Is another story.
So how do you model it flat?
Well, it's there's Rotman. I'm not pronouncing it right, but Riemann calculus, basically, where you create a curved surface and you flatten it out, right? Now do the
Right.
opposite.
Right?
So Earth can be a grid, and you can actually have two different grids, both in orthogonal planes. So you can have a polar grid and equator-based grid, and they can
Right.
overlap.
Right.
Two-dimensional planes stuck over top of each other.
Right.
And when you reverse it, when you take a flat and then you take all the points along the top and then you basically convert them into a single point, you can create a sphere. So you can spread that out. It's just like how they say all these different pyramids and everything face north. Well, if they're all facing straight up. It's a grid. They're all facing straight up. But when you like flatten that and bring them all together to a point, they're all pointing to north. But on a grid, they're all pointing up. So mathematically, you can model curved surface flat.
Which we do for many reasons, I think.
We do and we don't. We still convert it to geodesic lines. So what I'm saying is you don't have geodesic lines. Geodesic lines are actually the conversion of the points. Get rid of the conversion of the points and just create a square grid. And it's the wrapping into the conversion of a point that creates the geodesic lines. So we may observe, obviously we observe a curved surface, but we can mathematically model a curved surface as a flat two-dimensional plane.
Wow. After COVID, everyone was, out of their homes for like, 3 months, 4 months, whatnot. And I caught up with one of my best friends. And 2 cocktails in, he goes, I think the earth is flat. And I'm like, don't fucking start this thing with me. And it's just, everyone's just sitting at home and there's got nothing to do, working from home. They're all getting into these rabbit holes. And, but, this, Joe Rogan's the same thing. After COVID, he believes, we didn't go to the moon. Michelle Obama's got a dick. Pizzagate is real, and it's fascinating how, but what I love about the way that you look at the world is there are mathematical real reasons or ways that you can think of the earth being flat, for example, and there may be benefits for doing that. You don't have to turn it into a curved sort of mathematics just because that's the reality that we should always live in.
Mm-hmm. Yeah, it opens up a whole new way of, it's just perceiving what we observe versus what you can do through mathematics. And just like you see a line and a point, you can visually mentalize that and describe curved things as flat objects.
Yeah. So if Elon manages to get to the moon, do you think that's the first time you're going to the moon, or do you think that debunks the fact that we've been to the moon before?
Oh, I don't know. It'll be interesting to see if they find the original Apollo landing sites, right?
Yeah, but you can see them on Google Maps, like on Google Moon. Sorry. Do you think that's not real?
I got very there's a lot of editing on Google Maps, so
Okay.
I wouldn't be, I don't consider that evidence unless I saw
right.
the raw data.
Yeah, because they can just kind of put that in there as a photoshopped
Yeah.
image.
Yeah, so
But man,
there's
that's a tough one to lie about, man, because at some point
yeah,
somebody's gonna
no, I
go
know.
there and be like, "What the fuck?"
It is, yeah. If you think it's a lie and it's like, wait a minute, there's nothing around here.
Yeah,
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 it's
yeah.
a good call out, but maybe that's why nobody went back for so long. I don't know,
But
but
what was bizarre is SpaceX just did this like spacewalk thing. I don't know if you watched that. They did this mission with astronauts going into Earth's orbit, but at the outer orbit,
okay.
way past the International Space Station, and they were doing the spacewalk mission, and it wasn't really a spacewalk. I mean, it was just a guy standing on a ladder,
Okay.
popping his head out of this little capsule, and waving his hand, and then getting back in the capsule. Whereas we've seen spacewalks where people, they have like a rope attached to them, and they pretty much floating into space.
Yeah.
So it almost makes me wonder, is like, which one is real and which one's fake? Because if this is real, those ones look so fake because they look so amazing. These guys are just floating into space. It's almost like, have we lost that capability, or something is not right? Something is not real, because those ones look so amazing. Like when you watch Neil Armstrong on the moon and the pictures they're taking. But one thing that really confirms to me is there's a lot of editing that's gone into those clips. A lot of editing to a point is like they almost shot themselves on the foot because now it looks like it's fake.
Yeah,
If it was real.
it is real, and I think there's probably I try to think there's probably more evidence that it did happen than it did not happen, but like there's the experiment where they drop a feather and a bowling ball and they both land to the moon at the same time. You can't do that on Earth.
Yeah,
So there's little things like that.
I think you're gonna look so stupid if somebody goes there and they're like, here it is. And you're gonna be like, man, I feel so stupid. Because Joe Rogan is right in that category. He is adamant that we didn't go to the moon. There's no moon landing. And he is like putting all his money into that. So and he's good friends with Elon Musk, right? He's really good friends with Elon. Elon's been on his show many times, and Elon's like, no, we've been there. And so at some point, it's going to all come to that moment of truth.
Yeah, and then it'll all be, it was a fun conversation and debate for 50 years or 60 years, but it's been put
Exactly.
to an edge. Yeah.
Exactly.
Yeah, no, it's I think there's a lot of editing to your point, and in talking about NASA and what they do and don't do. I did find it interesting when I heard that pictures are the most valuable possession on any flight. So NASA will secure the cameras and the images of missions before they'll secure the astronauts.
Wow.
So out of the space shuttle, they say the space shuttle is coming out. Well, they secure all the imageries first, all the video feeds, everything, and then once all that's secured, then they'll go, okay, well, let's secure the astronauts. So that's what I read about, and somebody else confirmed that they found that out too. So yeah, why is that if they're full transparency?
Wow. That's bizarre. That's very interesting. Have you looked much into what the James Webb Telescope does and what it observes and
No,
how
not
much of?
really. I would love to do all that. It's just there's so much time in a day, so I try to focus on
Yeah.
what I.
So if you do that, you get out of your room. You're like, what happened? Oh, it's 2050. Welcome back out.
Yeah, exactly.
But it's so fascinating. I mean, the images they take is just like, wow.
Oh, it is. Yeah, the crisp of them, and yeah, just there's a lot of beauty out there for sure.
There's a lot of data as well. You can pretty much study what type of atmosphere a planet has.
Yeah, it's phenomenal. I saw a presentation by the advisor of I think it's the Canadian Space Agency, and he was walking through how you can figure out like you just said, the atmosphere of the planets, and it's phenomenal, phenomenal.
It's awesome. Well, this has been fun. Is there anything else you want to cover?
No, I think this is good. I just like the dialogue and open to any questions, but no, I'm really enjoying it. Thank you for this opportunity. This has been a lot
No,
of
it's
fun.
been awesome. No, it's been really good. Tell us where we can find your socials and your papers and things like that on the internet.
Yeah, sure. So my full name is Stephen D.P. Moore. So if you search that, I have ResearchGate has all my publications, my posters presented, and I have a Twitter account called @neokikilos, and the company I have that's running this up is called Varda Space, and that's what we're trying to launch into a new timekeeping system for the international community. And it'd be really exciting if that all pans out, because I think the technology is ready for prime time. So,
Absolutely. And so when do you think that this new paper and publication would kind of get some momentum and get all published?
well, so I have three published. The one that I have right now, it's in review. So that one comes out in the next print and press, if that is accepted. Of course, in academics, you don't know if you'll get accepted or not. That'll be in about, I think, February timeframe.
Yeah.
I'll put out a press release because I want to basically introduce it to. It's the concept of telling time and space that I hope I'll share with the international community. I present the ratio unit versus standard unit. I present the lunar terrarian calendar, so it's a calendar system for Earth and the Moon, and how this can be basically the first stage of the universal timekeeping system. So that'll probably be around February, press release around February, March, that kind of time frame.
Yeah, it's perfect timing because, we're getting Starship flights accelerated for 2025, and I think they're aiming to get to the moon by 2029. So there's a lot of, I think we're kind of like starting to get towards the other half of the validation that rockets, are pretty much good to go. We need to now start figuring out what that looks like for manned missions on the moon. How do we build the base? What do we need to take there? The logistics, the systems we need to build. the infrastructure we need to do. And so your paper is right at that core of all of that.
Yeah, it's the coordinating the time frames for all the devices and all the assets.
Absolutely. And that's it. And so if,
Yeah, and we've been talking to NASA a little bit. It's hard to get in. Talked a little bit to the Canadian Space Agency, hoping to get in contact with the European Space Agency to have them vet the technology. Right now, we have the Canadian Research Council reviewing the data and the information. Because if we could just get the bodies that be to review the technology, it's ready to kind of take the next step and build it into these consoles and these different computer systems that we'll need to take with us. So it's right when we need it.
Yeah, absolutely. I'm so excited. I'd love to have you back in February when you have the paper published and good to go. And it'll be a good time to really break that down and understand that a bit more, and I guess build a series of podcast episodes as we build our way towards having a much more better coordinated time system between Earth and the Moon and Mars and beyond. I think we have a mission now in one of the moons of Jupiter, I believe, which is studying. There's a high chance of frozen water and probably microbial life on there. So if we decide to have a much more presence on those moons, then your system and time measurement is going to be a great way for us to have a coordinated time system across all the planets and the moons that we are trying to colonize and occupy and create life and I guess create a universal system for human civilization. So that's quite fascinating to be involved in that. That's super cool.
Yeah, it's a lot of fun, and it was very foundational. So it's taking some time to build up, but we're making some headway, and we're excited to get to share it with the people. And I think we're right now, our next step is validating. We need some external experts to validate the relational system and how it works synergistically. I think the paper will be the way to kickstart all that. So we're looking forward to that.
That's awesome, man. Well, thanks a lot for coming on the show.
Thank you. This has been great.
Oh, awesome. Bye, everyone.